Here we are, my wonderful students, and we are doing another lesson with exponents here. We've been talking about polynomials, and we're going to use our lesson today to review some rules of exponents. Now, if I remember correctly, earlier in the year we did a little foldable, and I believe we've gone through the rules of exponents. So we should be able to hit this pretty quickly, except you're implementing a lot more complicated procedures than you would have done earlier in the year. I went ahead and wrote these notes out. That's for your benefit, not mine. I do know how to do this already, so this is for you. Just take your pencil and paper, write these notes out. Okay, this is a good practice for you, and it's a good reminder. We are on section 12.5. Today we are working on page 674. So I went ahead and wrote out all the rules of exponents here. And I wrote them out and gave you an example. So then we're going to work through the guided practice pretty quickly. But power of a product, all right? When we have terms, have variables inside the parentheses, and there's an exponent, it applies to both of those terms. Okay, so AB to the m power means A to the m times B to the m. And hopefully you'll remember as we go through how we apply that when we add exponents. But we'll get to that. So here I have 3a squared. Remember that means 3 squared times a squared. 3a is 9, and your answer is 9a squared. Okay, that's power of a product. Power of a quotient. When we're dividing and we have the exponent applies to both terms in the numerator and the denominator. For example, x over 5 to the third power, or x over 5 cubed, as we say, means x cubed over 5 cubed. In most of the cases, I want you to multiply that out and put that in that form. Not always. As the exponents get higher, sometimes we're just looking to see that you have followed the process correctly. So this final answer, x cubed over 125. Power of a power. There's where you have an exponent already in the parentheses and then one outside the parentheses. And when that happens, you multiply those exponents. Okay? So what does that mean? If I have x squared here cubed, then I'm doing x, and then my exponent becomes this exponent times this exponent, which is x to the 6th. I showed it here again with a number 4 cubed, and then to the third power. You multiply those exponents, that becomes 4 to the 9th. And this is one of those cases you can probably just leave it as 4 to the 9th instead of multiplying 4 times 4 times 4 times 4 times 4 times. So let's look. I'm at checkpoint. I'm going to go ahead and write this in blue, and we're going to keep that over there. Hopefully you're writing those notes, have written those notes. So, page 674, you can look at the other examples on your own. Okay, number 1 says 4y cubed. Number 2, I can list these pretty close because I'm not having to do a whole lot of solving here. To the 4th, number 3, negative 5m cubed, and number 4 is negative 7b squared. Okay, so what we're looking for here is to remember that this gets applied to both of these terms. So as I'm looking at this, all right, that means 4 cubed times y cubed, right? And 4 times 4 times 4 is 64 y cubed. Here, 3 to the 4th, x to the 4th. 3 times 3 times 3 times 3 is 81, x to the 4th. This is really important for you to recognize that when you have a negative sign and an odd exponent, your answer will be negative. Think it through. if I have an even exponent, meaning I'm squaring it, or twice, negative 5 times negative 5, and negative times a negative is a positive. Every even number is going to cause that to happen. But here we have an odd exponent, so I know my answer is going to be negative. So I have negative 5 cubed m cubed, negative 125 m cubed. Can you see that? Yeah, good. Okay, and then my last one, negative 7b squared. So hopefully you recognize I'm looking at it like this. That would be a parentheses around that. But it's an even exponent, so that's going to be positive. 49b squared. Pretty straightforward. I think based on what we've already learned in the beginning of the year, that's familiar. I'm going to go ahead and look at 5. And I'm just going to do a few because I think you know them. This is a over 6 squared. All right, a squared over 6 squared means I'm left with a squared over 36. Pretty straightforward in that section. I'll look at number 7 and number 9, only because those have negative signs or something that might look a little different to you, but hopefully you recognize if I'm squaring that, this becomes x squared on top in the numerator. Negative 9 times negative 9 is a positive 81. In the same way, number 8, last one on this section here, negative 2 to the 5th. Okay, it looks like that, right? Negative 2 to the 5th. Odd exponent means my answer is going to be odd. Okay, so negative 2 times negative 2 times negative 2 is going to give me a negative 32 over n to the 5th. You can write that negative sign out front and your fraction next to it. Either way, negative 32 over n to the 5th. So we breezed through those pretty quickly, but why make you sit here longer than you have to, right? Watch this exciting video. Just to give you pointers. So on the last one, here's where it does get a little tricky, and I'm going to take a little more room because you only want to have positive exponents when you do this. So when you have power of a power, they explain that again on page 575, which we've kind of done. And so I'm going to quickly look at number 9, and this is where it's straightforward, okay? 2 cubed to the 4th is 2, and you multiply these, is 2 to the 12th. Okay, you can leave it just like that. Now, look at number 10. Here's where it gets a little dicey. 5 squared to the negative 2 power. Okay? Have to pay attention to that. You still multiply those as usual, and you get negative 4. But the instructions say only use positive exponents. So when you have a negative exponent here, you want to put this term in the denominator to make it positive. So 5 to the negative 4, and hopefully you'll remember we've talked a little bit, is the same as writing 1 over 5 to the 4th. So when they say use only positive exponents, that means you can't leave that like that. You have to put it in the denominator. Let's look at another one like that. 12 is a to the negative 2 to the 5th. Okay? I multiply those and I get a to the negative 10. I cannot leave it like that. So I put it in the denominator with a positive exponent. Okay? It means 1 over a to the 10th. Now, if I look at number 16, just be careful not to get confused because x to the negative 3 to the negative 2, negative times negative, well, that becomes positive all on its own. I don't have a negative exponent for an answer, So I just leave it as it is on its own, okay? Lastly, example 4 on page 676. What I want to look at there is when you have scientific notation, how do you handle that? So let's look at number 17. And you have 3.1 times 10 to the 8th squared, I believe. Yes. The best way to consider this is thinking, oh, okay, I'm going to take this and square it. And if you do that on your calculator, make sure you put that in parentheses, because if you do 3.1 squared, all it will square is the 0.1. So be cautious of that. All right, times 10 to the 8th, and that's squared. All right, if I get my calculator out, I'm going to recognize 3.1 squared is 9.61 times 10. 8 times 2 is to the 16th power. Let's try one more like that. Number 18. I've got 2.1 times 10 to the negative 5. And I have that whole portion squared. Again, apply this to both terms. Square 2.1. Make sure you punch that in with parentheses so it squares the whole thing, not just the 0.1. 10 to the negative 5th squared. Okay, 2.21, I get 4.41. I multiply that other portion out and I get times 10 to the negative 10. Now in this case it says write your number in scientific notation. Scientific notation can have a negative exponent, and you've had some experience with that. So you can leave those in scientific notation in that form. Hopefully you took good notes. Hopefully the guided practice run through was helpful for you. Let me know if you have any questions. Good luck.